As we saw last week, it's possible in Haskell for functions to take other functions as arguments. It is also possible for functions to return functions as output. Functions that take them other functions as arguments are known as higher order, and we saw filter as our first foray into the world of higher order functions in the last video. Today I want you to think about this idea. If we have a list and we want to transform the values in some way, how do we do that? Well, you might say that we work through each element of the list, applying a function to it, and your head might naturally go to a for loop or a while loop. In Haskell, of course, we don't do that. So how do we do this? Well, we could write a function that applies an argument to every element, or function to every element of a list, if we were so inclined, or we could use another higher order function that is built into Haskell, which is called map. Now, let's have a look at the type of map. So you can see map takes a function from A to B, a list of A's, and returns a list of B's. Now, you might think, first of all, why are the types different? That's to give us more flexibility in how we apply it. You could also define map as something that goes from A to A and just change it into something of the same type. But by having different types, that allows us to have more flexibility in how we use it. Of course, at runtime, it could be that A and B are the same thing. It could be that we transform a list of ints into a list of ints. That is absolutely fine, but it could also be that we want to transform them into something different. Now, I've set up a list of bad films here, and I want to show you how we would apply some functions to it. So, let's look at map. We need a function from A to B, and we need a list of A's, and then we return some B's. So what I'm going to suggest is, first of all, we take the length of each element in the list. So what I can do is, map needs a function now as an argument, and I can give it the function length. And that's fine. And then I supply the argument x, that's our list, and it applies to each element of the list. Now, look how concise that code is. There's one line of code, it's incredibly concise, much nicer and neater than a for loop. But this is what map does. It just applies arguments to each element of the list, one by one, producing the output. So of course, if we wanted to, we can manipulate this. We could say, let's take the maximum from this transformed list, and we get the longest string in the list. So of course, Haskell, again, by not worrying about how we actually implement these in any particular order, or not any particular order, not worrying about how we worry or manage the state or the memory or the variables, we just abstract away, and it allows us to write incredibly concise code that lets us find the maximum element of a transformed list very, very simply. Now you'll notice up here I've imported a different package. This is just so I could show you another trick with a map. So say we wanted to transform a string to uppercase. So let's take the first film here, hard target. Then what would we do? Well, a string is a list, so we could apply toUpper, which works on characters. Let's have a look at the type of toUpper. It takes a character and returns a character. So it takes a lowercase character and returns the uppercase version. If it's already uppercase, it just returns the same version. You've seen this many times before in other languages. We did this in MIPS as well. But this is a very simple function. The problem is, we would have to apply this to every character in a list. So how do we do that? Well, we would have to do something like map to upper, and then let's just make up a string. So we just let's put some caps in there and mash the keys, and we get the uppercase list. Now, that's not particularly transformative. We just apply a function to a string, each element of a string. Of course, remember, strings are lists, so we have a bit of difficulty there. But how would we, say, apply this to every element of our list X? That becomes a little bit trickier. But what we can do is we can use map with itself. So I can say map, and I want to map over the list. So what I'm going to say is map to upper. And that's the function that it's going to take. So what this is going to do is it's going to map a function that applies to strings, which is this thing now, and we're going to apply it to X. And you can see that I've now mapped it over every single element of the list. So by using map, I can elevate something that works on one element of a list onto elements that are to lists of that element, and then onto lists of lists, which is what lists of strings are. Now, if we have a wee look at map, if we do :t map, actually let's put that in brackets just so we don't confuse the compiler, we get something that maps from string to string. So what I've done here is by using map, I've lifted toUpper to a higher level of application. I've lifted it from just characters to strings, And then when we use map on map to upper, we then elevate that to lists of strings, which is a list of lists. And we could keep playing this game if we were so inclined. So you could have incredibly complex data structures where you were just using map to map to map to map, so that you can apply this thing to lists of lists of lists of lists of lists. And this is the power of using higher order functions in a declarative language like Haskell. This is probably not something you would likely do in Java. You would probably use some built-in methods, but if you had to do this from scratch, as we were doing here, you would have to do something a lot more complex. You'd have for loops. You might have a for loop for every element. So you might have to do a for loop for each string, which is wrapped in a for loop of the whole list, or a while, whatever you prefer. But essentially in Haskell, we can do this in an incredibly short amount of code. So that's everything for today. I just want you to get the idea of the map function. We're going to see some more problems solved with the map function later on, but this is just a gentle introduction to it. It's just used to transform lists of one type into lists of another type, or to just transform lists to other lists. Actually, let's give you an example of that before we wrap up. So what I'm going to do is I'm going to use partial application again. So this is going to be a function that just adds 1, and I'm going to give you the list 1 to 10. And then, of course, I can just map that function over every element of the list, just adding 1 to each element of the list. So map can be incredibly simple. It can be used just to automate away a process, or it can be used to do something a little bit more complex, like where we raise the to upper function, as it were. But what I want you to get the idea of, map is just extremely useful for applying a transform into each element of the list, returning the whole list. That's everything for today. If you have any questions about this, please do let me know. Thanks.